So hello, welcome back. In this video, I'm going to show you an interesting screenshot that is to debug the RISC-V based vmcore. What I'm going to do is launch the crash utility program using the vmcore and the corresponding vim file. Please take a look at this. So I'm going to hit. So you can see that the vmcore is loaded using the crash utility. And another thing I'm going to remind you is that the vmcore is extracted from Vision 5.2 board. That is one of the popular board RISC-V devices available in the IT sector. As know that another widely used RISC-V based device is VigorBoard. So next time I'm going to capture the vmcore from that VigorBoard and then I'm going to show you how to run crash utility. So first thing I'm going to show you is this signature. Please take a look at this. Then version of the kernel is 6.620. Then what you can see is a message when the kernel panic occur. Then dump file name is vmcore and there are 4 core in the system. So first, I'm going to show you the kernel log when exception occurs in the Linux kernel. So for this, I'm going to use this command. Please take a look at this log m hit. So what you can see is the kernel message when the Vision 5 board is starting to boot up. Please take a look at this. And this is initialization message every time the RISC-V based device is start to boot up. Then SPI specification, SPI implementation can be seen. And please take a look at this, and you are going to observe another initialization message when the device driver is configured. So I am going down and down again to see the latest message in the kernel log. Okay, and 6 seconds, 7 seconds, and as you can see, the systemd is start to run to initialize the necessary configuration in this system. And at this point, and please take a look at this, and certainly, and the kernel panic message is displayed. Interesting signature is that, and this information is the set of general pop-up register in the RISC-V architecture. So please take a look at this. This register is some supervisor exception or encounter register that hold the address where exception occurred. And this register is return address register. That register is responsible for the holding having return address. Then here, and you can see another important register. Another thing you have to observe is cost. So this is one of the most important control and status register in RISC-V architecture. Then this information indicates that supervisor cause registers hold this value. It is known that the supervisor cause register used to have the exception code that represent the cause of exception. And another important register we have to take a look at is supervisor status register. Supervisor status register has several bit flag that represent the previous privilege mode, then the privilege interrupt state. So every time you have the crash issues, the first step to perform is to review those kind of register because this register tell us about the critical information at the moment of exception. Then here another interesting signature is the call stack, and please take a look at this. Then from this signature, and we can identify that our write system call is invoked from user space. The write system call handler is named as RISC-V syswrite. This is a typical convention to have the system call function that start with some name of the architecture along with the sys and write. This information is about the type of system call. If the read system call is invoked from the user space, we can have RISC-V sys read. From this function, we can identify that ksyswrite function is called from this function. And as you can see, the vfswrite function, that is one of the key primary kernel function in the virtual file system. From this software layer, then this function is called, that is a moment of exception. So another thing you have to do is to check the assembly instruction in this function. So, and I will copy this function to see the assembly instruction inside this function. For this, I have to use this command. Please take a look at this command. Then this is the name of the function. Give a hit. And please take a look at this. Surprisingly, we can see the RISC-V assembly instruction. Please take a look at this. And LKDTM exception function is consists of those kind of assembly instruction. So in this video, I show you the typical, the fundamental signature at the moment of exception from RISC-V based vmcore. The next video, I'm going to show you another interesting signature, that is interrupt. And then another thing I'm going to show you is some of the page information, that is, please take a look at this. When I use this command, and then I'll show you how the page, the virtual address is translated into the physical address. And this video will be available next time. Thank you for watching this video. See you next time.